Hey there, grade 6. New video for you guys today. This one is NS 6-32. It is focusing on equivalent fractions and multiplication. And so the learning target for you guys today is that you will find equivalent fractions using multiplication. So here we have this situation. A parent and child were sharing a cake, so the parent divided the cake into 2 pieces. The child wanted 2 pieces. So the parent cut the cake again and gave the child 2 pieces. So the question is, does the child actually get more cake? Well, the answer is no. And so what we have here is these 2 fractions. We have the first one is 1/2, and then after the parent cuts it, we have 2 out of 4. And so the fractions are equal because the pictures have the same amount of stuff that is shaded. And so we're going to just quickly look at how these are related with multiplication. We can say, well, if I multiply this stuff by 2, then that's going to give me, 2 out of 4. So both people get twice as many pieces, but they still get the same amount of cake as before. So these 2 fractions, they represent the same thing. You can copy the shapes in your notebook. What we're going to do is break each part in half to create equivalent fractions for the shaded part, and then we're going to write the fractions down. So what I'm going to do is, I'm going to change the color for a quick sec, maybe this color. So when I cut this in half or divide this in half, right, I started out with 1 out of 3, and after I cut it in half, then I got 2 out of 6. Over here, I start out with 2 out of 3, and when I break it in half, then I get 4 out of 6. Okay, and these things represent the same amount. The same amount of stuff is shaded, and the same amount of stuff is blank. Okay. All right, so the next one is focusing on breaking all parts into the same number of equal parts to create other equivalent fractions. And so the instruction here says signal how many times as many parts the first picture has as the second picture, which is a weird way of looking at this. I feel like I would have put this one first, but if you look at this original picture here, it's got 2 sections, and what I'm going to do is just draw some lines over here that kind of follow. Right, so this side now has 1, 2, 3, 4 parts, and this side has 1, 2, 3, 4 parts, which means that this has 8 parts total versus 2 parts over here, right? So this shape has 4 times as many parts as this side. This one here has 3, and this one now has 1, 2, 3, 4, 5, 6, right? And so we would say that this shape has 2 times as many parts as the first one. So then we have to signal how many times as many shaded parts there are, right? So if this piece here has 1 shaded part, this one now has 4 shaded parts, right? So it's 1 shaded part versus 4 shaded parts. It's still 4 times as many. This one has 1 shaded part. This one's now got 2 shaded parts. So that's got 2 times as many shaded parts. And then the last part of this is, well, okay, so let's write the equivalent fractions. So this one we know is just 1/2. And then so the equivalent fraction for this one would be 4 out of 8, because again, we keep saying that this has 4 times as many. This one we said had 2 times as many. This is 1/3. This is our fraction here. And this one is 2 out of 6. And those, again, are equivalent fractions. So the next thing that we're going to get a chance to do is just look at inequivalent fractions, both the numerator and denominator. And we saw that in these previous slides, right? So first one that we identified was this would be like our denominator. Then we look specifically at the numerators, right? The shaded stuff would represent our numerators. Then what we're doing is saying, okay, so let's put the numerator and denominator together. And then with this stuff up here, what we're identifying is this times 4 bit, right? So I like to call this our scale factor. In other words, what we would multiply one fraction by to find an equivalent fraction. It's kind of weird, right? Saying the word fraction but writing the word factor. Okay, so now what we're going to do is we're going to show how, or I'm going to show you how we can use a single picture to represent two equivalent fractions. Okay, so we have this picture here, and what we can do is you can use the same picture to show both fractions. You can look at the big parts or all the small parts. And what I mean by the big parts is if you look at this picture, it's like there's three rows, which would be our denominator, and then two of those rows are shaded in. So that we could say that this would represent 2/3. The other way to look at it is we count up all of the small squares, and so there are 12 small squares, but 8 of them are shaded in, and so we could say that that's 8/12, right? So I'd look at it in terms of the big square, the big shapes, or in terms of all the little shapes. Okay, and so that's the equivalent fraction that we're looking at. And if you look really carefully, you can figure out that the scale factor is times 4. So then what we can do is scroll down properly. There we go. So we could try to write two equivalent fractions, because one of the ways, if I go over here, this one looks at rows, and again I have 3 rows, and one of those rows is shaded in, or I could look at it that there are 9 rectangles and 3 of those rectangles are shaded in, so I can say that 1/3 is equivalent to 3/9. Here, instead of it being rows, it's columns, right? And so again, I have 3 columns, and one of those columns is shaded in, or I could look at it that I've got 6 rectangles and 2 of those rectangles are shaded in. So again, rows or columns for big pictures, which is going to help. Okay, so where we move on to next is trying to just use multiplication to write equivalent fractions, right? So how many parts do I have to break each piece into to get 12 parts altogether? Well, I've got 3 to start with, so each section has got to be broken into 4 parts, and that's going to give me 12 parts. That is, sorry, not great. But that means that I'm going to get 8 sections, 1, 2, 3, 4, 5, 6, 7, 8 sections all told. But what I need to realize is that I'm going to be using multiplication instead of a diagram. And so what I would need to do is to multiply to find the missing numerator. And so I look from this fraction to this fraction and say, well, what do I multiply to get from 5 to 15? Well, my scale factor there is going to be 3, which means that my numerator also has to get multiplied. So my missing numerator here is 3. To get from 4 to 16, it's times 4. And then again, same scale factor, so this becomes 12. And again, we're saying that these new fractions are equivalent. And again, there's a little bonus question here. To get from 100 to 1,000, it's just times 10, which is the same thing we do to the numerator. So the equivalent fraction is 150 out of 1,000. All right, so then what we can do is look at some skip counting. Right, and so we can skip count, right, like to find equivalent fractions. And so this would be like 3 times 2, and then it's 3 times 3, 3 times 4, 3 times 5. And so say, well, that's 6, and that's 9, and that's 12, and that's 15. And then down here we have it's 10, and it's 15, and it's 20, and it's 25. Right, and so that's skip counting. And skip counting is just a quick way to do multiplication as well. Right, so we would end up with 6 over 10 and 9 over 15 and 12 over 20 and 15 over 25. And that's a quick way to skip count a bunch of different equivalent fractions. Now, the next thing that we can look at, I think I skipped 2 slides actually. That's the next one, sorry. So then I want to write 4 equivalent fractions to 2 over 5, right? And so if I skip count, that would be 4, 6, 8, and 10. I'm going to write them as fractions here. So that's 10, 15, 20, and 25. And again, what I see is, this one's times a factor of 2, right? So 2 times 2 is 4, 5 times 2 is 10. This one's times 3, times 4, and then times 5. Now, we can also do improper fractions. So we looked a couple lessons ago about improper fractions, and we can see that this is 1, 2, 3, 4, 5, 6. It's 7 halves. Okay, so we saw that from a couple lessons ago. Now, anyway, if I were to draw a line through all of these and divide each of these shapes into 4, then I've all of a sudden got this many. I've got 14 out of 4, which is like taking 7 over 2, multiplying it by a factor of 2, which is going to give us our 14 out of 4. And so you can find equivalent fractions with improper fractions, right? And you can use multiplication and figure out the scale factor, right? So if I'm trying to get from 5 to 10, I know that that's times 2, which means this is going to be times 2, which will be 6. And then to get from 5 to 15, that's times 3. Same thing up here, times 3, which is going to give us 24. And so those are all the different ways that we can find equivalent fractions. We can use drawings, we can skip count, we can use scale factors for multiplication. It applies to improper fractions as well. Okay? And so what I'd like you to do now is you can get to work on the practice in the book, 151 to 153. And thanks for watching. Have yourself a great day.